All right. Hello, friends. That's a surprise stream. Let me zoom in. Boom. Yeah, I have to design the PCB, and why not streaming while doing it? That's how we gonna do it today. So I'll be doing a little bit of KiCad. We can try KiCad 9, by the way. Let me just save everything and close my... I have changed a few things since last time. Well, it will be updated in a second. Hey, M.2 You are the first in the surprise stream. Wait, did I even install? Hey, CoolPad. Did I even install KiCad 9? I think I didn't. Let's try it. Hey, Quindor. Oh, yeah, all right. I also stream on Twitch, so I can... No, you only YouTube. I could either rate you afterwards. But I can send my viewers over. I will stream until 10 o'clock. Hey, Konstantin. Hey, Sonic. So, since last time, let's try that and hope it doesn't... Why now, lol? Hey, Jordi. Why not? Around? Okay. Oh, who else is streaming right now, Jordi? My stream will be boring, only PCB design. Chris, living room, workbench. Oh, all right. So, Adam, hello. So, wait, before... Here. So, I checked a few designs. Last time we started... Oh, where's KiCad? I'm sorry. Let's see if it works. New KiCad. Okay, let's import settings. It looks identical. Ah! Window control still messed up. Look, I have a kilometer long and wide window here. Shoot. Okay. Copy default global symbol library table. Oh! I hope my stuff still works. Okay, I cleaned up the footprints from last time. Here you go. That's how my symbol looks like. New addition. I'm using the B plus M key. Because, I mean, why limit to M if B would also work? There is an PCI Express, and the common denominator. Hey Joe, save Oh yeah. Yes, let's save it. Um, so there is the common denominator of M and B key is PCI Express or SATA drives, and I made two footprints for that. I can maybe show them. And okay, let's with all the signals. So there is. Oh, that's the footprint. No, symbol. Oh, interesting. 2080. Why is this like an extra symbol right now? Yeah, I don't know. Don't know. Okay. So this is now the SATA. It has like the M.2 thing has like configuration pins, but from the documentation we got like how to connect it. So ground would be for SATA and PCI Express. I have it on this side. One is not connected. Oops, sorry, you can see. Let me shift it over. This is 9. That looks like this identical to 7 from behavior and everything. So this needs to be tied to ground, and yeah, we have plenty of NC and mounting point. I just hit them from the main view. So now we only need to do that and be good. I checked the documentation to find out clock requirements. So usually this, I think this isn't even on the PCI Express. I don't think on all PCI Express connectors. Reading documentation, yeah. Or let's say I pasted the PDF into ChatGPT and let them make like answer my questions to that. So basically we have some PCI Express stuff. One is important because in our, let me show, this is the design. Typical PCI Express. Oh, chat window is hiding everything. This is now, I sorted my windows as well, my browser windows, to have everything. Why did it? I hope your Chinese is good, because the Chinese data sheet. So this is PCI Express, and you see PCI Express reset. That's like not reset. So this is basically resetting our interface chip. Refresher to you. Maybe I should start with what we are doing. So I'm trying to design an M.2 card and using WCH, an interface chip from PCI Express to serial, parallel, whatever. We only need the serial. So there's nothing complex about that. Cool, but look at that. Okay, I show you around. This is just the main chip. Here is some configuration. So there is like open blah blah blah. So these are 0. That's just jumpers. Then you have a jumper here, whatever, and okay, this is a jumper, an actual jumper. This is 0 ohms resistor. These are just capacitors. capacitor, and this is 1.8 voltage regulator. So we get 1.8 volts here to this part, and 3.3 from PCI Express, and these are just decoupling caps. Nothing else. This chip is optional. That stores the vendor information and stuff like that. So if you go into your device manager or whatever, the PCI Express device identifies itself with vendor name, whatever. You can store this information. If you don't have this chip on the board, it will be just identified like WCH. So nothing special here. Our serial number. All right. bitluni PCI Express. Yeah, that would be cool. Yeah, I would be totally stoked if I can manage to make an actual PC accessory or a peripheral. There is this is the PCI Express. You can see TDI. I don't think we have this even. You connect. This is just PCI Express, so times 1 port. There is something. I think it's because of to measure the timings. You connect one pin to the furthest one away. So I maybe the bus, I'm not sure about that. The bus can measure the maximum delay or whatever. So we don't have that on M.2. This is also not present, but we have the wake signal. Wake, not wake. It's basically whenever the PC is coming like from sleep state or whatever, wake will be pulled down. So we can do whatever. Hey Yumbo, do whatever we like. Reset is when we have like a PCI Express bus reset, and every single of the devices can pull it down, I believe, to indicate they're not ready yet. So once they're all loaded and ready to go, let's say in that case this chip would detect there is a reset or would be powered up or whatever. It will pull down the reset, read this chip, the information. Once it's ready, it will let go of the reset, which will go high if all other PCI Express devices that are, I think this is individual, but then it's sure, okay, that device is ready to be talked to. So this is clear. Then we have this, we don't have auxiliary or 12 volts on M.2. Oh no, they canceled the game you were playing. What? Which game were you playing? So there is not much complexity, and crystal is also optional. So you can, there is like, I think the spec is 0.27% or something precision if you use the internal PLL clock. You have like the PCI Express reference clock is 100 megahertz. I don't know if the chip uses that. Where did I read it? I think I read it in the longer version of this. Yeah, in the longer version of this document, because it's, I think, just a, yeah, that's not the one. Oh really? They're common? Why this frequency? Is this for serial, like to have to have like a proper serial signal, or it divides it to get 115 to 100, or what's the frequency there? Doesn't look like perfectly to your pulse. Yeah, nice. Yeah, so yeah, I don't think I need that to be so precise. I will add the footprint for that, but I don't think I have the space, or I will use this teeny tiny crystal for that. It's actually optional. So this is just to get this going, and then you have two parallel ports and two serial ports available. And my idea was now, so we want to build a cluster. This is we checked. Let me show you the PCB, our test PCB. Yeah, whatever, copy. Okay, this is our test PCB. Test PCB. Oh yeah, I decided not to angle it. We will just do 90 degrees and use it like that. So this is, yeah, save it, whatever. That's still messy. See pixel errors here. Hey, cosine. So if we take a look at the 3D viewer, yeah, Ix, here we go. Yeah, it will, we have space for 8 maybe of those. This is the interface chip. Unfortunately, there is no QFN version, so yeah. And this is the CH32V208. What speed going? Which one? I mean, this is the UART can go up to, I think, 8 megabits. Let me check that again. Can take a look. Can find it though. This is the other pink LED. No pink LED. Sorry. Maybe we can do pink LEDs or white LEDs if we don't want to use resistors. Where's my data sheet? Okay, let me check that. Here. Okay, so this is the English version. Speed, pink lasers. Oh, that will be hard. I mean, you need some kind of phosphor mixture. Look at that, 0.27 at 115.2 kilobits per second. Oh, that's the division obtained by the, okay. If it's acceptable, I'll take it. Oh. So yeah, that's the clock selection. Either 7.812 megabits per second or 114.9. We can do 115.2 only with the oscillator. Let's see valid, we can check. Otherwise, this is external crystal of 20. That can do. Frequency division doubling is 2.7. Interestingly, if you use internal PLS 125 megahertz, you can talk faster if you use like the internal PLL. So strange. You can do 2 megabits or 8. I think 2 megabits is fine. Oh, hey, Rohan Divark. So, for what is basically, it will be an expansion card to put a microcontroller on there that will control more expansion cards, which will be mounted vertically, and those will have 16 or 32 RISC-V MCUs, so it will be a cluster. By the way, I found what I was seeing there are connectors that would fit in this direction, but they're not obtainable. Either it's the wrong key, or yeah, this hole here is right at the edge. But if you look at expansion cards for vertical M.2, it's a different key, but it wouldn't matter because we have the same amount of pins most of the time. If you look at that thing fits in the right size. It looks even like the right one, but they're not obtainable. It's really hard to get them. Let me take a look from the bottom. Oh yeah, look at that. Here. It would fit if we use this connector, but they're not. I tried to source at LCSC the M key ones, and they said I need to buy 120 pieces at once, and they're quite pricey. Let me check. I will share my availability on that here. So this is the one that we use now. Similar version. Which one is it? Yes, actually yes. Packet switch IC. Yeah, I will use WCH interface to serial, basically PCI Express to serial. I don't want to develop drivers, and using the serial chip, it will be way easier to work with, because you can use the browser to access your cluster from on the PC, which is really cool, and it's way easier on Windows and also on I mean, on Linux it's no difference. Probably you can always access the devices. Here, these are, there are 10 pieces. This one, I think this is the wrong key. Yeah, this is the E key. The E key is available, M key is not. So annoying. Either we have to do like E key or switch and use that, or we, same here, you see out of stock 76 cents M key, not available. Real size is 650 pieces. I tried to order. You can do a JLC. You can order like 10 pieces to add to your stock, but they refunded me today and said, oh no, you need to buy 700 pieces to get them. So very unfortunate. But also we have here, this is also E key. I think this was E. Hey, which one was it? I think this is E as well. They have a few pieces there. So I'm not sure what to do. We can try to get the footprint. Wait, this is DigiKey. We got our last footprints also from DigiKey. Where is it? Huh? How do we download it? Johnny, I said there is a chance that I will stream today. Yeah, I think this is the E key. Yeah, I think this is E. This Adam tag. Adam tag, which is actually not Adam tag because it's a different tag. China tag. I saw also on AliExpress the image looked like M key, but they say it is E key. Similar sizes. Quite narrow. I don't know if Isla will allow me to get this drill so close to the edge of the board. To certainly break. I'm dying to say the same since forever. Look at this, I have tea. Casper. Okay, where's my footprint? Let me get The issue is also, yeah, this is the add-in tag. The issue with a simple post on Discord. In advance, you mean? Not just when it starts. I have the green star so I can what I want. At least in the live channel on the Discord, you get notified whenever the live channel is starting. I'm so sorry. It may say, oh, you're reading your emails. Green members. Oh, all right. Never mind. I came up with a few ideas. Now we have the goal for today would be to. Oh, I have other things that I need to talk about. So this is the interface chip. The parent will be why doesn't it show it? The 208. So I want to interface the 208, which will... The interesting thing is that you don't know yet, but I do, is that we can program WCH chips over serial as well. And the interesting part is, let me find the window. Looks like I didn't. Let me find that. That's not the one. Here. GitHub repository. Here we go. So, WCH Web ISP. Issues wide code is so Basil Hussein made web programmer for WCH chips, and you can just upload the firmware, and here are the details for that. We are using 208, at least I want to do that to control the bus or whatever, do the interfacing to the cluster, and have all the others connected to it. What we need to set is boot 0 to 1, boot 1 to 0, and then use this communication interface. I hope this is correct. I need to double check that with our specs. Where is my pen? My pen. Okay, I have a pen. So PA9, PA10. So we need to control boot pins. because just having that work, like that we can program upload a firmware to our main controller is already a big plus, so you don't need the linky there. This is the first step. Maybe we should make a list. Let me create a list actually. Okay. CI. Okay, so design. Hi Alexander. Yeah, many CH32, but also PCI Express interface. Okay, M.2 B plus M card with or let's do that with PCI Express PCIe. Okay, that's the to-do list. We did that thing already. Then we need to interface yes, parent or master, whatever you like to call it. And then there won't be any intermediate ones, just all the other chips. So CH38.2 382, sorry, I'm thinking that's like a PCI Express to that. Then we need that to CH32V208 8 BU. I think it was WBU type. It doesn't matter. Then we need a little bit of fun. That's like nice to have. I will tell you in a second what we can do there. So we have stuff that we can do. Okay, so this chip only communicates with PCI Express, but we have stuff like LED1, which I believe is the HDD LED, because this is meant for, the interface is meant for hard drives. So if you have a SATA drive or SSD drive, they will just pull down whenever there is like access to the hard drive. So we can actually control that using our microcontroller for whatever reason, just communicating or blinking or whatever. That would be nice to have that. So we want that signal. That's HDD LED. Let's do. I think that's the one. LED 1. Was it LED 1? Yeah. then, interesting, we have whenever like in suspend, or that's why it's sus, it's not suspicious, it's suspend clock. And that's just an real-time clock from the main board, which is also available in sleep mode. So we have actually like a slow clock here, and I'm wondering what we can do with that. So I will at least try to feed the WCH, the CH208 with that, and I think there might be some possibilities to use that clock for whatever stuff. So 32K clock. And then we have also like this one is mandatory. We might want to be able, I will pull it up for sure. I mean, pull it down because we need this clock, the PCI Express clock. So I will pull it down. So this is just meant, the clock request is just meant on the PCI Express bus to have ultra low power consumption. So basically what happens is that the bus chip, whatever it is, switch or whatever, can turn off the clocks to the peripherals unless they pull that down and say, oh, I need that clock right now. So if you want like power conservation, you leave that floating and it might disappear, and then it's up to you to request the clock again whenever, let's say, you get the wake symbol, wake call. So I will do it with 10K. Let's do 10K like that. To ground. And then we will add a new clock request symbol. Oh, wait, we can do that, but we don't need, we can use this label as well because we don't want it on the sub sheets. Clock request, and we will use that maybe if we try to monitor it or whatever, we can use one pin of the main MCU to handle that. So what else is there? We have the reset. The reset is used, and wake is basically whenever it's pulled down, whenever PC is starting up after a sleep. I believe it was like that, yeah. So we can also use that here. And maybe even on an interrupt pin if we have like deep sleep mode, but I'm not like, that's like overthinking. That's just a nice to have. So let's do wake. And that's actually all we get on the PCI Express ×1. This one is not connected. We only use one PCI Express lane. The reference clock, 100 megahertz. And fun signals here. The request that we pull down. And configuration is basically preset to communicate that the M.2, this is only like on the M.2 PCI port. Hey, the Shipu. this configuration is basically to indicate that there is an PCI Express SSD connected. But actually we don't use SSD. We will use the PCI Express. Hopefully it works for that chip. All right. Yeah, we have RX and TX here. Now I'm really cautious in thinking of doing an RX-TX bridge so we can swap the signals if they are wrong. But let's just YOLO. I will just expose the traces to the top layer for long enough so we can cut the trace and modify it if necessary. Now let's check if our datasheet is correct. So where's the pin map? FPGA, CPLD. We can use CPLD here, memory and bus. Wait, where are the pins? Or do I need to take datasheet 0? Yeah. So yeah, WBU6. We can put this. It has Bluetooth, but we won't use it. Just like I did here. No Bluetooth used, but the chip. Chip is nice. Okay. So let's check pins, peripherals. Oh, that's a long data sheet. That's even... Oh, here we go. Pin alternate functions. No. Main functions. Some switching. That's the one. 208. Wait, is it 208? Yeah. So we wanted PA9, PA9 and 10. Okay, so we have USART TX, USART 1 RX. So we need to switch those and have the A10. Okay, let's do the interface. Wait, here. So serial or RA, serial reset circuit, steal from P1 mini. Now spoiler alert, you know where my design for that is coming from. TX first. TX is 9. Okay. TX is 9. So we put Rx here and Tx here, because this is Rx and this is Tx. 9 should be Tx. 9 Tx. Okay, this is correct. We got that covered. So how do we check? We mark it, we comment it out. That design, I think the design is ready. BM PCI Express card. PCI Express is not ready. We are using serial TX and then reset circuit. And now that's the interesting part. Where is my reset circuit? Get it through dry mouth already. It was our research. Do I have the resets? I show you. Wait, this is the wrong. Here. So, interesting thing. The UMH3N, there are just two transistors. As like logic, we have confusing, RST is reset, and we have RTS, which is ready terminal system or whatever. I will show you what that means. So, on the ESP8266 or ready to send, oh yeah, here we go. Hey, Talk Therapy live. So we have ready to send and data terminal ready. We have set signals, ready to send, data terminal ready. These are the output signals of serial that we can send. There is also the break, but that's not used everywhere, interestingly. Or request to send, okay. Request to send data terminal ready. So basically, if you have controlled serial that uses like, that indicates whenever buffer is full or not full, you can use those signals. But we can use those signals to reset the ESP32 or ESP8266 or our CH32 in this case. We will just take exactly the same thing with our, here's the info over serial using blah blah blah, entering programming boot. So reset needs to be 0. This is it reboot. Unfortunately, the symbols that KiCad has are two separate transistors. Yeah, flow control. So we can use those signals DTR, RTS, basically to, here, reset is pulled down whenever DTR is high, RTS is low, and boot is pulled down whenever RTS. Oh, what level do we need? Oh, wait, we need 1. So we might need to switch that. That sequence. Hey Ian. I have no clue how to do it right now. Let me check. So right now I just copied it, and instead of pin 0 we have boot, and I think pin 0 was also okay. So on the ESP it needs to be pulled down, so we might need to invert for the programming. The boot sequence on that blah 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 blah. I think boot mode. It's strange. So I think it's boot from system memory is what indicates to use serial to upload. But it's not stated here. I think that it's in the other data sheet. This one here. Oh, no, wrong. This one. Oh, wait. The memory cannot be erased or programmed in the system boot code area. Blah, blah, blah. Ah, okay. Here we go. That's the table. So, in that case, that's what we want from system memory. What I'm wondering, how do we use the two lines to basically do that. We need a different chip for that, don't we? No, wait. We would need DTR is pulled down. So in this case, let me write this down. Hey Artem. So I don't know if anyone is familiar with how the DTR RTS sequence. Maybe someone can find it for me. Sequence on ESP is basically, oops. On the ESP will be, it seems so that we have DTR DTR1 RTS 0 reset. Why is there a space? Where is the space? Okay. And then 0 would be DTR must be 0. RTS. So 1 is You know what's strange? I thought GPIO 0 needs to be pulled down. Pull down while pressing the reset or while releasing it. So the switch needs to be really fast. We need to verify this. On. So this is reset. It's too big. Let's do that. Let's assume that that would be the sequence. Now we need the logic to achieve that. This is wrong. Oh yeah, wait. Let's do that. And let's do that so we are sure. reset 1 IO 1. Yeah, that will be the result basically. Quindo, we have still an hour before Quindo starts. Yako. Sorry. I will only stream until 10, so there is plenty of time. Still, I hope. I don't know how long Quindo streams. So, how do we do this? Logic table. MS Paint for help. Is there a state? I mean, we ignore the states anyways. But is there a state that's set by the computer? I don't think there is a state. So what I would like is we have a reset B0 B1 and we have DTR RTS DTR RTS. Wait. This is not what I want. I want a different kind of table. Oh wait, yeah, it is. It is that. Okay, I want something that's comparable to ESP with DTR is 1. So reset will be high. We don't want, or we can use always something. Oh wait, not high. Z. No, wait. Huh? No, wait, this is wrong. Again, that's embarrassing now. Let's do it here. So we need set reset 0. Board 0 1. Board 1 0. And we need or we can ignore that. We can, I mean, the boots, that would be the best. And then we can try to do a truth table for that. How do we do the Z? There is no truth table, no logic. Is there any logic for high Z? I mean, in that case, this would be floating if DTR is 0. So this just disconnected. RTS, we can always add more. So this is basically, oh, the next state is 1 or Z, doesn't matter, or boot or Z, it's easier. I'm not sure what the logic is behind the ESP that they wanted the signals to flip. Is there a reason for that? I mean, if you don't have full control of the serial. Because in that case, we can just add another chip and do the logic like that. Where is the reset here? Or is it not reset here? That's the one. Okay, so we have pull up, now we get several reset signals. Maybe we call it RST 32, okay? Let's call it that. But what I don't understand, DTR RTS. Okay, we can do that. I understand this is how it works. Now, boot. Both taken low is a lockout state, so same effect as both being set high. We can check what happens. Okay, both low is normal computation. Both high normal computation, low, high DTR will be connected. So it's not really... Is there anything else? Okay. Let's check this side here. No. I would check the web programmer. What was the signal name? Ah. Huh? How did I lose my window again? Where is my window? There. Okay. Let's just look for that and we should find it. So this is the reset. Triggering reset. Set signals. Data terminal. Oh yeah. Data terminal. Oh, interesting. Request to... That's just a reset. There is a reset without boot mode. Sleep. Is there more? Ah. That's the only thing. Okay. Many details here. Okay. RTS goes low, DTR goes low. Oh, interesting. There are different configurations. Strange. Oh wow. Yeah, this is what we need. By Arduino, it's different way around. Pin reset, it's flipped. Why? But strangely, they just ground it. And there is the option to DTR. Or RTS. Oh, you can pick the signal, but this is also to ground. So we might not overthink this and just we can budget afterwards. The issue is I need to invert it though. So I need more than just two. Or I ignore boot 1. No, that's shit. This is So we need a sequence, just reset, and we need a sequence okay. I have a solution. But we need to do some logic for that. We can use DTR we can use reset not equals, let's do it like logic, not tr, not DTR, boot 0 equals RTS boot 1 equals RTS and reset, no, DTR. not DTR, boot 0 RTS. Oh no, that won't work. How can we represent three states? We need 2 states after reset. No, 3 states after reset. There are 3 states. Either boot 0, or we just ignore it. There won't be from RAM. Here. Not reset, yeah. Boot 0, this is what we need. High Z would be nice, but I don't care. People are gone. Is this even working? Oh. Is bitluni dead? Yeah, it's gone. Okay. So we can do a reset here, RTS DTR. Here, this is our DTR as the reset. And then we have boot boot 0. Okay. Wait. This is wrong. So close. Stupid Telegram. Where is it? Here. Simulated. Yeah, that would be nice. How do I invert my boot 1, boot 0? This will be 1. No. Yeah, I need PNP. What's the part name? Crashed. N. That's the wrong one. What's the part for the PNP? Hey Dave. VC. Oh yeah, we can just use a single one. What's common here? 5. That's all TO packages. Let's do sort. That's 40. Yeah. Wait, we need to move that. Here. Oh. Ah! And there we need And this one will be you know what? I don't actually care about that one. We don't need, like, we can just use a single transistor here. We can directly connect what is the emitter? What is the collector? Mirror it. Like that? Okay. I'm wondering if maybe we use, how about switching to NMOS? No, we don't want to the power to flow down. Okay, so NPN. What did we use here? PC8. Ah, do we need like a resistor in here? Thanks for the follow, Nedemika. Ah, 857847. Okay. BC857. BC 847. I take it. Do I need a resistor here? What value? Ah, let me check the UMH manual datasheet. Uh, 4.7 input resistance. Is this what they mean? I have no idea about transistor logic. So we can leave it like that. Here's a different one if it doesn't work. Here? Wait, emitter here? Here. Yeah, we can always add like 1K, but I don't want to like so it's more resilient. R6. It will be glowing slightly. Wait, this is okay. Boot 0. Yeah. This is boot 1. How do I simulate it from KiCad? Capacitors? Why? You're spoiling my circuit. External spice tools, like our funky spice. I would say we just do it. Just do it and see what happens. We just commit it. Or you can use the nice tool that we used before here. That one. Should we do a new file? Magic Smart Containment System. MOSFETs, transistors. Huh? Oh, that's a circuit. Wait. Okay. Let me rebuild that. Which one are we building? That's the... Ah! Oh, that's a slider, okay. Oh, this is so annoying. Wait, here. Okay, passive components. Ah. Let's do this one first. Oops. Okay. A reset, I think that will be a slight pull-up or something. Yeah, no, the reset, there is a 10K reset here. That's independent from our reset circuit. Oh, what did we get? Oh, did someone sub? Oh, follow. Thanks, tier 1. Okay, so actually, let me do that. Let's leave it like that, and there will be a resistor. This is 10K. Okay. And this is scope. Huh? How do I edit it? All right. What did we have here? that's certainly, that needs, wait, this is the wrong circuit, sorry. It's 1K, 10K, 10K, 1K, okay. Did it die? Run. It died. What did I do? Yeah. Oh no. Oops. No darling. Yeah. Ah. If you want to simulate this, do it yourself. I'm just wasting time right now. Let's do more design and less here. You can screenshot it and simulate it yourself. And then test what will happen. You want a pull-up on the reset. Yeah, there is a pull-up on the reset. It's here. It's independent. Okay, you're annoyed that it's not in the same place, so I will move it. Here. Are you happy now? Oh, are you happy now? Pop, para, 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 pop, pop, pop. Pop, para, pop, 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 happy now. Pick it up, yeah. Okay, whatever. So I would say reset circuit. Demonetized. Yeah, it was spot on. Are you happy now? That's my "Are you happy now" song. Not you're in the. I think the only word in common was now. Do it yourself, yes. Splicer now. Oh wait, did I? It would still work. Okay, let's check our to-do list. I would say the sim is called here fast ladder job for circuits. Here, I give you can. The best part is the URL encodes the circuit, so you can just share the URL and be good. So, what else do we need from this CH? Oh. What else do we need? I think we have... The interesting part is we have that, and there are the output signals are we can use that to communicate somehow. I'm not sure. We can extra signals. We could wire them to. We could do. We could do though. Wait. Set signals. Maybe we have a third one that we could use. At the end. Break. No. No. That's the ring, I think. We will just add labels and connect it to our... So we have DCD. Ring. DSR. CTS. But I'm not sure if we want to use that. These are optional. Let's put it optional case. Wait. Can we draw? No, I'll do optional. Optional fun stuff. So this will be and I think this is no. Now I would like to complete this circuit. that we needed. Where is it? It's gone again. Here. This one here. 24 CO2. 24 CO2. How do we? You can probably program that with a Flash programmer. But this will be interesting. How do we? Can we write that from the PC? Oh, what? Busman! Hello! Thanks for the raid! Nice. 2 kilobyte TSS subsoic. What is the difference? T-sub. Yeah, S-sub. Okay. Nice. Hey, Bossman, what did you do today? What did I miss on your stream? Soik? Yeah, Soik, I said that. T-sop, T-sop, Tsop. Okay, so this is SCLSDA. I think they want this. Oh, isn't that like very tedious? Surface Pro. I think the Surface Pro might still be the easiest one. Every single of my displays are broken. Like I broke my mobile phone screen and my tablet. I don't know if you can see that. Wait. You can see there is one crack in the middle, and I don't know. I'm using the cover all the time. There was probably a grain of sand or something in between, slapped it and cracked the whole way through. 2 hours plus. Oh man, almost not worth it. You have some patience. Okay, SCLSDA. All to ground. Ground. Saarbrücken for you mean for demo scene party? Is this revision in Saarbrücken? No. Easter party. I can't. My girlfriend would kill me. So sorry, I can't do this. Yeah, unfortunately, can't do family time. I'm old now. Where is it? Where is it? Here we go. This was all ground, was it? Oh, there's the cap. Ground WP, not C. What is this? We need to probably program this before we conclude. Streamer killed by girlfriend. Yeah. I'm not even sure if I consider myself a streamer. We need a cap here, so let's add a cap. 100N, we can steal one here. And do it. Oof. Yeah, this is... It won't win any prizes. Beauty contest. I don't know, content creator, I must say. So mixed. So rarely that I upload a video nowadays. Can't even claim that name for myself. So this is just for this is the flash. So for the people who are raiding, this is an PCI Express to serial and parallel ports. So we can do a sound card here. What is Covox? Covox sound card. 2 serial ports and a tiny table Lumi. Yeah. There will be tiny tables at some point. I mean, I think the tape outs for more of the demo scene stuff is coming soon. I need to check because I'm a judge on that part, but there were already like super insane contributions for that. I still need to convince myself, or running it in silicon. First meme. Yeah, no, I believe there were other memes before before Johnny before Rickroll. I also associate Rickroll always with Johnny Baghdad. So this is serial to PCI Express to serial, and this chip only stores the device information. So if I want to call it like device M.2 PCI Express bitluni whatever card, I need to store it here, otherwise it's optional. Now we have a ton of caps. SPI. Yeah, I mean we have. Let me check that. There are already teasers from. I think on FPGA they were tested already, but let me. I think this is. I need to check here. Here, TTA demo scene entries. Wait, what? They are simulated so far on FPGA. Wow. Here you go. Here you go. This one is cool. Oh, they're so. This is insane. This is insane. I'm really looking forward to. Let me check TT8 when it's ready, when it will be shipped. Closed. Here. They're coming soon. 1 month, peeps. Estimated delivery date. I will probably receive one. We can test them maybe on stream. That would be really nice. But that's after Easter party, unfortunately. So imagine we can test them and stream all the entries here. I think Matt will ship me for the judging the entries. Will ship me one device, and then maybe we will do a community vote. No name votes here. I know how it works in the demo scene. Name voting, free beer voting. Actually, I have no clue how it is nowadays. All right, so yeah. Oh, I can drop the link if you are interested in watching the demos. They have been emulated. I will get a VGA mod, but I think I also have one. I can always here are the entries, so you can enjoy them. They have been run on. Oh, look at that! That's a Doom on ASIC. Should we watch a sim? I don't want to spoil everything. Okay, let me check if this the classic zoom from Panic or whatever back then. Whoa, with sound. Let's give you sound. Here. Ah, that's amazing. I love it already. Okay. That's not on the chip. But that's cool. Looking forward to testing them. It's really cool. Meta balls. Oh wait, nice. Flame demo. The new versions of the Tiny Tape Out demo scene, whatever, there will be a gaming competition as well. I think inputs were requested. Like, I need to get updated on that, but it's really cool. All right. Back to our contraption here. I have only 1 hour left.
Yep, hat made game P mods for that.
Game P, yeah. Nice.
Sternchen joystick.
Oh, ici.
What kind of joystick?
À placer.
Like the classic C64 joystick or PS2. I think PS2. PlayStation 2 joysticks were easy, or Super Nintendo. They're just shift registers. Easy ones. All right, let's add the caps. So we have two. We need the voltage regulator for that. Where am I? Here. We need LDO. Yeah, we need to find one. I don't think I have one in my standard repertoire. I might have some in the basement. Yeah, we take something really small. How much current does it take? Let's check. VCC. $170 milliamps. It doesn't say of if 3.3 or whatever. Okay. So not a high requirement here. 1.8 MSOP.
It's SNES based https
super database, nice.
github.com/psychogen.
Yeah. Yeah. He got the connectors. Nice. Yeah, that's what I also use for my 10-player game console. Is it here? I made a 10-player game console on the ESP32 and took it to the Maker Faire, and we had actually like 10 kids standing around and playing Tron on the ESP with VGA output. Also with 10 of those shitty controllers, not the original ones. I got some shitty clones from AliExpress.
Tron seems good.
Yeah, for 10 players it's the best. I think there was like Ultimate Tron on C64 where everyone would get like 2 keys to turn around, and you could play on one keyboard like many players. So I thought, yeah, I would just do exactly the same thing. Yeah, that's too many connectors. I want something like SOT.
NT rollover back then. Nice. TTS on Master B. TV.
What? Oh, sorry.
Lül.
Sorry. Here we go. Need to turn it off again. All the TTS, yeah. Now you know how it feels to be me. Which one is quite common? I don't know. LTM? Nah. I want some low profile. SOIC 8. No. SOIC. SOT. Here we go. This is the ones. 5-pin. LDO. With shutdown. We don't need shutdown actually. Wait, that's 150 milliamps. That's not much. Good night, Bossman. Thanks for the raid. You know what? I will just take one that's widely available at Mauser or whatever. I take the cheapest one from Mauser. So, what footprint? Optical interport connect between the rig boards? Optical risk. Oh, yeah. Optical interconnect. Okay. We can put fiber optics. Multiple PCI Express cards with fiber optics. Or what did you think? Like, I mean, is it? Are you taking it serious? M.2 12. Now we want something. SC SOIC SOT 3 2 5 3 SOT 23 5. Yeah, whatever. That's the footprint I like. SFP cable between two boards. I'm not no expert in such things. Okay, price. Now let's put sorted 9 cents. That is our part. No, wait, this is our part. Texas Instruments, whatever. Datasheet, what current do we get? 300 milliamps, good enough. I take that. True fiber communication trapping late ray of light. 10G, yeah. Oof. Okay. What is the most common? No, too big. TCR, that looks shitty. I take it. LP2985, what is this? Maybe that's what I'm looking for. What kind, is this good? 150 mil. Oh yeah, that would be easier. I want huh? Yeah. Can sort by the inventory. 18,000 TLV. The naming is shit. 4. Okay, let's do 300 milliamps and above. Only. Active in stock. $5,006. Yeah, I have in stock. Normally stocked 30,000. 28 TPS. Is this the one? Is this the one? Diodes incorporated. Oh, 290,000 times. That's the 3.3 volts. Okay, we need to find the 1.8. Here we go. Up to 1. Okay. Here we go. Oh wait, that's the wrong one. 1, okay. 1.8, 600. Yeah, here we go. This is the one I wanted. Here, V out. So let's put the power. It's cramped here. I feel cramped. Close this. This will go to external sheets anyways. This will go here. You feel pressure. Are you under pressure? Okay, now let's clone that. Our circuits. Big monitor, I have 4. Okay, I will move this over here. They are excessive with the caps here. What do they want from me? Wait a second, this is a song text. Are you trolling me? So, how many caps? They want 4 caps. Of which we have 110U and 3 it's not that easy. Oh, really? Yeah, but I'm using cheap ass stuff from enable is basically vin. Yeah, and people are keeping just this stupid yeah, I do that sometimes. We don't need to populate them. Just put them somewhere. And oh, there is another one. What the F? Shit. Doesn't fit here. Yeah, the distance doesn't match. They won't be, I mean, it's PCI Express, so it's not messing around with, we have a 100 megahertz clock there. Bezels? What are bezels? A million hertz? Yeah, $1 million. But Dr. Evil, our multinational corporation, does a yearly revenue of $2 billion. Something like that. Do you remember? Here we go. And this one is 10. Ooh. That's what they want. Very excessive, I must admit. Yeah, pain in the okay, there is a selection that's I think this might be even, we'll check that. That's how do I mark something? Because this is a selection here. Oh yes. That's the selection if we want printer port. That's R4. MD printer. Wait, open is 2 serial. Short R3. So this is selecting printer, but I'm wondering why it's not PRT, because it says when it's open, oh wait, both are open means we have serial. Okay. Oh, it's so strange. Okay, here we go. Show you what's the thing here. So if we want only one, so both unpopulated, we have 2 serial ports. This one populated, we have 2 serial and 1 parallel port. So basically that's the maximum configuration that we can get. Would be nice to have that, because then we can... I'm not sure if we need a second... Oh wait, there is no single serial, that's always 2 serial. We just select if we want a parallel port or not. So very simple. How do I do it infinite? Or do not populate? Exclude do not populate. Okay. Basically that. And I will add the node. Wait. Wrong. Wrong one. Full configuration is R4 is open. Okay. So makes sense. Okay, whatever. Then we have ref is 12K down. I need to check what's that. Funny. It's even number 12 resistor. 12K. Did I forget? Reset CKS. Clock select. Hello. Hey, foo. Busies. Oh, yeah. Oh, I see that. Bizzles. That's some switching noise, huh? You need a picofarad cap or something. You might need... No, we don't want in line. We'll try. No, wait. What do you need? You need probably inductor in series or something. Ugh. Forget it. Don't take me to take my advice, because cap doesn't charge as fast as this peak is happening. I don't know, maybe you need a low pass filter, so cap and a resistor in series, cap to ground, and then like a low value. Maybe you can simulate that. Yeah, so we need to limit the current output while charging the cap. Johnny, this was my, you passed the test. You passed the test. That was my challenge. Challenge, if you will notice, you personally will notice that. Oh, it's annoying, but it works. Nice. Okay, we need jumper. Bridge door opened. 3. Hey, what? Oh, and not populate. Okay, wait. Let me do it. Ah. Huh? What? Deprecated or what? What's the issue? I shouldn't have updated. It didn't help. It only destroyed my workflow. Huh? What's going on? Why is this dead? I have no clue what's going on. Why is it crossed out? Is it because it's... Oh, it's because it's excluded from simulation? Okay, interesting. Okay, so we have both open. And we have CKS. Yeah. CK cell. Oh, nice. Now it's even more cramped. Who built this symbol here? Did we do this? This is terrible. Who does that? You put voltages up there. Yeah, I did this. Damn it. Zika cell. And then we have ground. And we have reset. That's clock select. Clock select. Open is normal, whatever that means. GND fast on TSPLL. So we rather want to PLL it, huh? Maybe we should jumper let's set to PLL first, and okay, but what I don't get is, huh? Hey, we checked that. That's one thing that was missing. Huh? Why do they put 100 nanofarads capacitor here? Because that's like close. That's the PCI Express bus. I don't get it. There is already one on that side. I will not... They want one here for whatever reason. I don't get it. Wake is open, reset per prop. Then it's the ACLS ACK. We can get those symbols and then we are ready. Then we are finished with this part at least. No, that was clock select. That was ICK. That's parallel port. Parallel port stuff that we can busy. Oh, come on. Huh? Why? Busy air. P. Cells. Init. Sin. AfD. STB. I call it PD0, okay, for parallel port. Huh? 7 Y move done. Okay. I think we need just to clarify clock clock select. Okay, so we did PCI Express. We need clock select here. How is that working? Then we have fun. Then we have CH. We can do either sound, built-in sound, or LEDs. Matrix 4x4. We have more signals than just the parallel ones. But which one are sent by the terminal? Covox. Yeah, I could. I could do. Uh, hmm. Hey, Christian. Okay. We just need to find out. This is so much fun. I might stream even more often. I'm not sure. Maybe Monday. So you are warned. Data sheet. Crystal X1 capacitors are used in a clock oscillation circuit. Oh, we might need a clock oscillator. We didn't do that. If we need the oscillator though. If the clock cell is connected to reset pin, the X can be omitted. Other capacitors are used for power supply decoupling. The capacitor with capacity is a tantalum capacitor. Okay. No, not putting there. 10 microfarads, and there is ceramic which are connected parallel to the power pins respectively. Oh, SCL. Yeah. Okay. Oh, these are CK combination selection. So this is just a clock select. You have one that spits fire? Where is this? Is this a configuration bit that you can set from serial port register? Oh yeah, okay. So you can change the configuration. All right. Okay, yeah, I would only add the crystal just for the sake that we might want to use it at some point. So, crystal. Yeah. How is it here? I don't see it. Ah. Crystal. Crystal. Two-pin crystal. It's time for me to end the stream and go to sleep, huh? Ah! Value is $11.84 mH. It's a test, yeah, for sure. I'm always testing. Can never feel safe here. Okay. Oof. How do I... It's cramped. Why is it so cramped again? Go. Oh no. Shoot. Okay. Go away. $27p. And then we do that and do not populate, do not populate, do not populate. Easy peasy. I think we are done. 10 o'clock, that was my goal. We have, oh yeah, the CH is a little bit deserted. We need to take care of the CH32 next time. And then we will do our matrix. So pink matrix next time. No series resistors or capacitors to ground? Where? Wait, what? What are you talking about? So, peeps, I'm done for today. Thanks for joining the stream. Thanks for raiding, subbing, following. And we will raid. Oh, anyone who is on YouTube, go to Quindor and please give me an advice where to go with them with Twitch. Give me a Twitch channel. Yeah, I will tell her. Okay, who do we raid? Raid channel. Is anyone? Ravoioli. Time 58 minutes. Oh, 423. Yeah, let's go there. Oh, there's PC building time. Okay, so that fits the theme. That fits the team. Thanks YouTube, and I see you next time.